Hi there, I'm Ralph Ellis. I'm the course manager for A-Level Computer Science. The A-Level in Computer Science is a really good course for students who are genuinely interested in understanding why computers work in the way that they do. And that's going from high-level coding, understanding how that gets turned into machine code, which the processor can run. We also look at how the arithmetic logic unit can be designed as a series of logic gates and what Boolean algebra can be used to represent that.
It will be very, very useful in the future because it's just so wide and it can be applied to almost everything in the field. Like, you just learn about everything from like all the programming stuff to just how like a CPU works.
So in the course, as well as the very practical elements of being able to code, that also develops students' ability to problem solve and work very independently. And they have very transferable skills no matter what the student wants to go on to look at in the future. So throughout the course, we look at a variety of topics. We also, throughout the course, help students to develop their own programming skills. There will be an expectation that students are learning to code in the class and in their own time. So if it isn't already, programming should become your hobby.
Yeah, I wasn't expecting to have as much programming as I have been able to, but every single lesson, you just get loads of time to program.
We use Visual Studio, which is free to download. In Visual Studio, you can develop your Visual Basic coding, which I use in the class, or you can use it to develop C#, and there are other programming languages in there available also. So students do need to keep in mind that it is a largely theoretical and abstract course. And although there's a practical element to it, the course is not solely about learning to program. And in fact, the main reason we look at programming languages is to get a better understanding of the structures, the iterations, and the dictionaries that are used in the programming language. The way we deliver the course in computer science is using a flipped learning approach. Students will do the preparation for each lesson at home as part of their homework, using a variety of resources. And in their classroom, we'll consolidate that understanding the students have developed from home. And the advantage of that is that not only can students learn at their own rate, but when they're given a task they need to complete to see how much they've understood, the teacher is there to support them. The flipped learning approach also increases students' sense of independent learning, which is also beneficial when they go into university or go into a workplace environment. Before the end of the first year, students will set up and run their own NEA project. And this can largely be on a topic of their own choice. So through the second year, they will do some analysis, they'll look at designing that project, they put a technical implementation in place, then test and evaluate what they've produced. That forms 20% of their final grade. The other 80% is made up of 2 exams at the end of the second year. One largely on programming topics, which will include a practical element where students have to write a program in those exam conditions on screen. And the second paper is a more traditional pen-on paper, covers the theory elements of the course. Many of our students go on to university. Some study computer science, some to study something related to computer science, cybersecurity, or software design, or games design. More and more of our students are getting involved in degree-level apprenticeships. We've even had some students go off to GCHQ to do a cybersecurity apprenticeship. So every year, we run a trip to Bletchley Park and the National Museum of Computing. Students get a real sense of the history and the development of computing and technology through the last century. So to support students studying computer science or any other subjects, we run some enrichments in college.
Ralph holds a coding club every Tuesday and I attend that every week, and it just gets me to do some extra programming just to get some extra experience from the classwork.
It is not a requirement to have studied computer science at GCSE. It might give you a small advantage, but as soon as you get into an A-level topic, the breadth of topics and the technical depth of understanding, which makes it an A-level, is something that all students will have to learn and develop, whether they've studied computer science at GCSE or not.
It's really, really intriguing just seeing how everything works just inside a computer, just to make an amazing machine, really.
Some of the reasons that I really enjoy teaching computer science is there's a wide range of topics that we cover, and we also try and think about what's going to happen with technology in the future. In fact, if we've got students studying computer science now, the jobs that they will have in 5-6 years' time probably haven't been invented yet. So why should students study computer science? Well, students are developing understanding of the latest in technology, and as we move into the future, that understanding of that technology is going to benefit those students across any possible career they might get involved in.
You get loads of experience programming, and Ralph's, the teacher, is always there just to help you if you need any help. I really, really do recommend it to anyone.
So I thoroughly encourage you to consider computer science here at Richard Huish College, and I hope to see you soon. Thank you very much.